Hello guys, this is Kumar Singh. Today I'm going to start a topic of mathematics which is known as metric space. Before knowing what is a metric space, we should at first learn the definition of metric. The definition of metric is very simple and it is easy to understand. The definition is, at first, let us consider a non-empty set. Let us consider a non-empty set X. And also consider a mapping D which is from X cross X to R, where R is the set of real numbers. Let us consider a non-empty set X and a mapping D from X cross X. X cross X means the Cartesian product of X with itself, and the mapping is going from X cross X to R, where R is the set of real numbers. Then the function D is said to be, a metric, defined on X, if this satisfies the following properties. What are the properties? The properties are, the first property is d of x comma y is greater than or equal to 0. D of x comma y is greater than or equal to 0 for all values of x comma y belongs to X. D is also read as here distance between X and Y. The function D is also known as distance function. Defined on X. So D of x comma y, we also mean that distance between X and Y. The distance between X and Y is always greater than or equal to 0. And it is very sure that if we take any 2 point, say X, if we take any 2 point X and Y from the set X, then the distance either be 0 or greater than 0, but never be less than 0. That is, distance never be negative. So the first property is distance between X and Y is greater than or equal to 0 for all values of X and Y belongs to X. The second property is distance between X and Y is equal to 0. If and only if X is equal to Y for all values of X, Y belongs to X. And it is also very clear that if we take any 2 point X and Y, then the distance becomes 0 if the points be same, if X and Y be coincided. Then the distance becomes 0. That means X and Y will coincided. So it equal to 0 implies that X is equal to Y. And also on the other hand side, conversely, we can say X is equal to Y. It means that distance between these points is 0 for all values of X, Y belongs to X. The third one is, if we take distance between X and Y, then we also can say it is equal to that distance of X and Y, distance between X and Y for all values of X, Y belongs to X. Distance between X and Y is equal to distance between Y and X. It means that if we consider here distance between Mumbai and Delhi, then Mumbai to Delhi, the distance will be covered, the same distance will be covered from Delhi to Mumbai. If we cover a distance from Mumbai to Delhi, the distance which will be covered, the same distance will be covered from Delhi to Mumbai. That is, distance from X to Y is equal to distance from Y to X. So D of X comma Y is equal to D of Y comma X for all values of X, Y belongs to X. The fourth property is distance between X and Z. Is less than or equal to distance between X and Y plus distance between Y and Z. This means that if we take 3 points X, Y and Z, then distance between XZ, this is D of X comma Z. Distance between X and Y, it is D of X comma Y. Distance between YZ, this is D of Y comma Z. And as we know that if we take any side of a triangle, it will be always lesser or equal to the sum of other two if we take any two sides, if we take any one side of a triangle, if we take any one side of a triangle, then it will be lesser or equal to the sum of other two. That is, distance between x and z, distance between x and z is lesser or equal to distance between x and y plus distance between y and z. That is, d of x comma z lesser or equal to distance between x and y plus distance between y and z for all values of x, y, z belongs to x. Now, if this satisfies all these property, so this is said to be a metric on x. D is said to be a metric on x, and x with the metric d, that is the order pair x comma d, is said to be a metric space. D is said to be a metric defined on x, and the set x with the metric d is said to be a metric space. The first and second property is known as non-negative property. Non-negative property, and some writers refer as it positiveness property. The third one is known as symmetric property, and fourth one is known as triangle property. So if you like this lecture, then the next will be coming soon, and the next lecture will be on some examples of metric spaces. The familiar metric spaces, that is usual metric space, discrete metric space, and also more on about it. So if you guys like this lecture, please support us.